We are ready to start assembling, and one of the things we could look at doing is to tile all of our open files. That gets a little bit busy, so maybe not. There we go, get back, and so clicking on one of the pieces, the other options here is in the viewport. We can look at the part from different views, and the length, the front, and the top. So pretty much like a drawing, but that doesn't really help me. So let's see, we can either go back to new window, or sorry, viewport and single view, or double click and double click. I'll put this back in there. So we need a method to access the parts easily. So let's go ahead and get into an assembly. And since I haven't created a metric assembly, let's go with the default assembly. And we'll have a choice of starting the command when creating new assembly. This is going to be our begin assembly. Since I'm going to make a template real quick, I don't want that on right now. I don't really like the view origins in the assembly. It kind of starts to take over after a while, all the little blue dots. So I'm going to switch to millimeters, grams, and seconds, go to my document units. We'll double check that we have 2 and 3 for pieces. I can't think of anything right offhand. Maybe we'll go isometric, Control 7, and then File, Save As, and we'll look for the assembly template. Okay, so find that, and I put those under my Dropbox 2020 system templates. Assembly, I think I had millimeters on the other one, so we'll go millimeters, metric, and save. Alright, so again, I don't want to retain any information in this template, so I'm going to go ahead and close, go back to new, and under my templates, now I'll have an assembly millimeters. Okay, so if we go to the list, then the first thing that I would want to bring in is we're looking at the base slider. And I'm not getting a preview. So let's try the check mark, see if my computer will catch up. Alright, there it goes. Not quite sure. That may have been the way too many files open. Alright, so it comes in the fixed position. And if I look at the origin of the assembly, and then we expand out and we look at the origin, that checkbox put origin to origin, and since I drew the part, created that part in the orientation, I really don't have to do anything. If I wanted to rotate this or change its orientation, then I would have to right click and float. Since I'm pretty happy with its current position, we're just going to leave it with the F for fixed in its current position. Alright, so we have a couple different ways of bringing in parts. Since I have all the parts open, I'm going to come over to the file in my task pane and open in SolidWorks. So I have to kind of decide which way I'm going to assemble this from. We have the pin short, so really need to kind of put those in place. And if this was a standard dowel pin, we'd have to decide if we wanted the chamfer. But we're going to go through pretty much the same process that we've done previously. So select. I'm going to highlight faces over edges and select. Don't be shy about zooming up onto the area. And in the pop-up, I can see the concentric. If you would prefer, you can come up to the paper clip, and it will show concentric. And at that point, we'll lock rotation as well. So locking rotation isn't 100% necessary, but it is going to allow, once we come up with a distance, it does allow this to be fully defined. So select and control select the face. We could go to the bottom. I want to see a distance, and since it's 10 millimeters long, we'll go with 5 millimeters. So if I look at that from the side view, then if that were pressed all the way in, actually it looks like it was pressed a little bit too far. So let's go back to the drawing and see what I could measure it in the model. But we had, that was a 10 millimeter piece, and the pin was 16 millimeters. So let's adjust. So the distance went that way, so let's raise it up 7 millimeters. Alright, so that's a little bit shy of the bottom, and if the 10 millimeters on the support works out, we'll still have plenty of clearance. Alright, so I want these pins to move the same, and I'm using the middle scroll wheel to kind of do the zoom. Picking on the pin, holding down the control button, I can drag in another instance, and I can do a mate, an active mate. It'll go to concentric. We'll lock the rotation, and I want these all to be driven off of the same distance, so I can make the two faces coincident, and if I change this one, then I will also be changing that one. In 2020, the button pops up to flip the mate alignment, so it's active. Okay, so we'll keep going with the drag and drop. Again, holding down the control button, select the pin. This time I'm going to do it from the feature manager when I drag it into place. So this one is not getting the mate. So since I don't have the part, I'm not getting the location. So lock rotation is fine, and then we'll pick the two faces and I'll make them all go to the same, and then back to the pin, drag it in. That's going to give me the I call them marshmallows. We'll lock the rotation one more time and place those. Alright, so usually I wait for the hardware, but since the supports are going to go on top, we can use those pins for our mate alignment. And I have a minus sign, so on that one I did not get the rotation locked. Alright, so it's not a big deal if it's minus, because it's just going to allow the pin, as long as it doesn't move up and down side to side within our degrees of freedom, should be okay. Alright, so I come back over, we can look at the open in SolidWorks. I can grab the support when it comes in. We're going to control select, go to concentric, give myself a little bit more room. I didn't need to reverse the mate alignment or to lock the rotation, so we'll bypass that little pop-up. and if there was misalignment, if there was variation in the dimensions, then it would pop up with a warning and allow you to misalign. But most of the time we want to verify and make sure that what we've selected is okay. So I rotate around, and the bottom of the support to the top of the base, that gives me my location. And then we're going to hold down the control button, drag it in. Alright, so there's not really anything to select to. It's trying to find planes based on what I picked, and based on what I picked I didn't really get anything. So one of the advantages of lining this up with the pins is going to be that if something happens, if there is a change in the dimension, something unexpected, then there's a good possibility that the mate will error, and it gives us a way of checking as we go through the process. Alright, so I missed that face. There we go. So we select, rotate around, hold down the control button, pick the next face, go into coincident. Alright, so we're doing a lot of repetitive motions. We're picking the mates somewhat like we do the references, the relations in the sketch. Alright, so we'll keep going with the bringing in the rod. So if it moves out, or based on my pick, so if I bring that in, try to locate. So since there's no mate relation set up for that, we'll just go ahead and hit the control button and select the two faces, go coincident, pops up. We're going to lock the rotation, and I'm going to pick the end point and control select the end of the support, make those coincident. So when I rotate around, I expect these to be flush, and I can do a quick measurement just by selecting the face of the support, and the normal distance is going to be 0 millimeters. If there was some gap or some variation there, I'd be able to pick that up. Okay, so let's go ahead and open. Oh, I keep clicking that one. Let's go ahead and open the slider. Alright, and it's already open, so basically that's just swapping to screens. I'll put it back. And so we have this this tool under the reference geometry called a mate reference. And I'm going to pick the cylinder. And it's going to be any of the mates, tangent or concentric. Well, let's go ahead and force it to be concentric. And then any of the mate alignments. So once I've created that, it's going to create a mate references folder, and then I can save it. We'll switch back to the assembly, and since I have too many open for it to list, we'll go back over to our file explorer. Oh yeah, probably should save that at some point. So since we're in the mode 5-17 for the slider, and we'll save and jump over here real quick, slider assembly. Alright, so that time I just double clicked, put me back in. We'll go into File Explorer. If I drag the slider, now this one will find that concentric mate because of the mate reference. Alright, so it's already in. I don't necessarily want to lock the rotation. That could be problematic, and we have to decide if this is going to be dynamic. And so that can rotate, which is fine. Our choice here is, do I want to go plane to plane? So front plane doesn't help me. Top plane to top plane would be okay. Right plane to right plane. Oh, maybe not. Right plane to front plane. Alright, we'll just keep selecting until we find it. I don't really want to go coincident in case there is a little bit of mismatch in this. I want to stay parallel. So that gives it a little bit of float, because when we do the analysis and we optimize for this part, right now we have an 8mm shaft going through an 8mm bore. Technically, that slider won't move. And if we get it on there, it's not going to have the clearances to be able to move back and forth. Alright, so I thought I got the rod, concentric, coincident. Oh. So I'm not sure what the rod is capable of doing, but it's not moving unexpectedly, so I'm just kind of checking those minus signs as I go. Alright, so we'll do one more, and then we'll in the next video come back and look at the rotational motion. Alright, so the pin is looks like we're just going to bring in another one of the short pins. Actually, that one should have been a little bit longer. So have the driver pin is in piece, and I'm pretty sure I'm looking right at it and short. Well, maybe not. We'll have to decide on that one. Double check 16mm. No. And in the assembly view, it doesn't look like one of the specialty. Alright, so bring it in if we need to make an adjustment. Since I can't see it, to drag it in, I'm going to drag from the feature from our component list, and we'll go concentric and lock the rotation. See if that did it that time. All right, so the circle's filled in. All right, so this is able to move up and down. So this time I'm going to try to go, let's just go face to edge. So that'll be fully seated into the slider. And we'll make those coincident. And that'll get us our first result. We'll start building from the other direction. And at some point we'll want to look at making a configuration that generates a static and one static and one dynamic configuration, so that we can control the movement on this part. So